This is section 6.7, graphing linear inequalities in two variables. A linear equation in two variables has an x and a y, and it looks like the equation of a line, but the equal sign is now replaced by a less than or greater than sign. So it's an inequality, but with an x and a y in it. An example of a linear inequality is 3x plus y is less than 6, or x minus 4y is greater than 8. The signs can also have equal signs attached, so it could be less than or equal to, or greater than or equal to. So for example, the ones that are below, 2x minus 4y is less than or equal to 24, and 0.5x plus 0.33y is greater than or equal to 100. These are all examples of inequalities with two variables. The solution of a linear inequality is an ordered pair, an x and a y coordinate, that makes an inequality true. So to test, you have to substitute the given coordinates and see if the inequality remains true. So what they'll do is they'll give you an inequality and they'll give you a point and say, is it a solution to the inequality? So you'll be substituting that point into the inequality. Keep the solution on the right-hand side because you want to see if the values of x and y are actually less than 6 without moving the 6 around at all. So we're going to put 0, 0 in. So we have 0 minus 3 times 0. And is that less than 6? 0 is less than 6. That's true. So 0, 0 is a solution of the inequality. The graph of an inequality is on a coordinate plane, and it's the set of all points that represent all solutions of the inequality. First, you draw a boundary line that's going to divide the coordinate plane into two sections, and you'll shade the region that actually satisfies the inequality, that holds all the solutions. So there are three steps here. The first is to graph the boundary line. You're going to use a dashed line for a less than or greater than, and a solid line for a less than an equal to or a greater than or equal to. In the second step, you're going to test a point on one side of the line. I usually use the easiest point, usually 0, 0, especially if it's not on the line. It's just easier to plug 0, 0 in for x and y than anything else. And then last, shade the half of the plane with the tested point if it works in the inequality, and the other half of the coordinate plane if the point does not work in the inequality. So here's an example. We're going to graph this inequality. It's y is greater than 4x minus 3. So you're going to graph it just like you would a line. I usually put it in y equals mx plus b form. I find that's the easiest way to graph. Because there's no equal sign here, our line is going to be dashed. So I drew this line, I plotted a couple points. When I looked at it, the first thing I saw was that the y-intercept is -3, so I put that here, and then I saw the slope was 4, so I went up 4 and over 1, and up 4 and over 1, and then I put my dashed line. Now we have to look at the shading. So we're going to test a point 0, 0 and see if it works. Well, when you put 0, 0 in here, you get 0 is greater than -3. That is, in fact, true. So you're going to shade that side of the line, the side with the 0, 0 on it. So I would shade all over in this section over here. Okay? All over this side of the line. Now we're going to graph the inequality x plus 2y is less than or equal to 0. Again, we're going to rewrite it in y equals mx plus b form. So I keep the y's on the left-hand side. I brought the x over, so it's 2y is less than or equal to -x, or y is less than or equal to -1/2 x. I divided by 2 there. Okay, so you see that there's no y-intercept, so we're going to cross the origin. And the slope is -1/2, so I came down 1 and over 2 and down 1 and over 2. So I have this line that's going from the second quadrant down to the fourth quadrant. It's a solid line because I had a less than or equal to there. I'm going to test a point that's not on the line. 0 is on the line, so you should stay away from that. So I'm going to test 1, 1. That's above the line. And when I put 1, 1 in there, I see that 1 is not less than negative 1/2. So we're going to actually shade the other half of the line. So we pick up our pen and we shade this side of the line this time. Sorry about that, I went over a little bit. But it's going to be below the line because y is less than that line. You're going to see that you're going to start to see a pattern here. Then when y is less than an amount like this, that you're going to be shading below the line. I still want you to test a point every time just to confirm your suspicions there, if you would. Now we're going to look at linear inequalities in one variable. Now when they only have one variable, that means it's either a horizontal or a vertical line because there's just an x or just a y. So we're going to use the same method. We're going to graph y is greater than or equal to negative 3. So we're going to graph it just as if it were y equals negative 3. That is a horizontal line going across at negative 3. Because it has a greater than or equal to sign, it's going to be a solid line. And because all values of y must be greater than negative 3, you're going to shade above the line. Shade above the line. So we're going to shade all of this up here. Okay. You can test a point to be sure. I would test 0, 0. Is 0 greater than or equal to negative 3? It is. So you're correct to shade above the line there. Now we're going to graph a vertical line. We have x is less than 2. So we're actually going to put a point at 2. Get this going here. Put a point at 2. And we're going to draw a line here. There we go. Sorry about that little mistake there. When x is less than 2, we actually want it to be dashed, so make sure your line is dashed. And because x is less than 2, we have to decide what side of the line we're going to shade on. Test a point. Does 0, 0 work? Is 0 less than 2? It is. So we're going to get our pen that's a color, and we're going to shade all to the left of this, because where the 0 is actually works here. You can solve problems with this graphing method. For example, if you have 2 jobs for the summer, one earns you $8 an hour teaching basketball and another $10 an hour teaching swimming, and you want to earn at least $200 per week, we want to find out the different combinations of hours you could teach each sport and write an inequality that describes your goal. So if we let x equal the number of hours teaching basketball and y equal the number of hours teaching swimming, then we would come up with something like this. 8x plus 10y is greater than or equal to 200. You're going to graph that equation and shade the area of possible work hours that could give you $200 a week, so you could see all the different combinations. Now, because the hours can only be positive, you only have to graph this in the first quadrant because you can't have negative hours for teaching either basketball or swimming. I would rewrite it to make the graphing easier, although you could use the method of finding the y-intercept and x-intercept and just connecting the 2 points if you would like. But when I rewrote it in y equals mx plus b form, I got y is greater than or equal to negative 0.8x plus 20. The line you draw should end up looking like this. It's going to have a negative slope. It starts at 20 and drops all the way until it crosses at 25 on the x-axis. When you substitute 0, 0 in the equation, you find it does not work. So you should be shading above the line. So any point up here would work in combination. Okay, any one at all, including the points that are on the line. So that's a solid line there. And what does this mean? It means that any XY combination of hours worked above the line would earn you at least $200 a month. Anytime you go above the line, it's more than $200. Okay, on the line, it's exactly $200. So you should understand what these graphs mean.